Hi everyone. Today I'll be assisting you in how to solve systems of equations. These questions typically show up on standardized tests, pre-algebra, algebra 1 concepts, and I'll just be helping you with these. Alright, so there are a few different methods and I'll be going over 4 in this video. So the first one is solving by subtraction. So how can you recognize one? Well, if you see one equation above the other and both equations have one variable that has the same coefficient and charge means positively or negatively, so like if it has a plus or minus before it, and you could subtract the bottom equation from the top. Okay, so here's an example. As you can see in an example, the first step is to identify that we should solve this system of equations by solving the bottom from the top. And as you can see, they have the same coefficients and the same charge, 2x, 2x. So 2 is a coefficient, they're both equivalent, and they're both positive. None of them are negative. So we know we could subtract the bottom from the top. As you can see in the second step, I actually put the negative sign to indicate that we're subtracting it. And then we break it down into individual components in step 3. So 2x minus 2x equals 0x, right, which is 0. 8y minus 2y is equal to 6y. 16 minus 10 is equal to 6. So at the end, we are left with 6y equals 6. And if we divide both sides by 6, we will get y equals 1. And then finally, we could plug this back in to one of our original equations. In this case, I just plugged it into the second part. So 2x plus 2y equals 10. So 2x plus 2, and obviously y is equal to 1. So 2 into 1 equals 10, right? And then we go on. 2x plus 2 into 1 is 2 equal 10. Subtract both sides by 2, and you get 2x equals 8. If you divide both sides by 2, now you get x equals 4. And then finally, we are writing it in an xy coordinate, so it would be 4, 1. And this is just one of the ways to solve systems of linear equations. All right, so the second way we could do it is by addition. So addition is ideal when you could identify that both variables have the same coefficient. I mean, like the last example, we had 2x, 2x. But they have different charges, so one of them might have a positive before the 2, and then the other might have a negative in front of the 2. All right. So in this example, as you can see, we have x plus 2y equals negative 1, and negative x plus y equals 3. So as you can see, the x and the x are the same. One of them is positively charged, and the other is negatively charged. Okay, so in this case, I indicated that we added these two by putting the plus sign. And again, we could go through the individual components. So x plus negative x is just x minus x, which is 0x. 2y plus y is equal to 3y. And then negative 1 plus 3 is equal to 2. So again, in step 4, you can see that 3y equals 2. We divide both sides by 3 to isolate for y, and we get y equals 2/3. Now again, we have to plug it into one of the original equations to get the value of x. So I just plugged it into the second part, and I got negative x plus y, which is 2/3. So negative x plus 2/3 equals 3. I subtracted both sides by 2/3, and 3 is also 9/3. So 9/3 minus 2/3 is equal to 7/3. So negative x equals 7/3. I divided by negative to make x positive, and I got x equals negative 7/3. So then I put it again into an xy coordinate form, which is negative 7/3, 2/3 in xy. And that's our solution. All right, the third example that I'm going to be going over is solving by substitution. Well, the substitution method, we solve one of the equations for one variable, and then substitute the result of that into the second equation to solve for the second variable. We can only solve for one variable at a time, and this is the reason the substitution method is extremely valuable. So here we have a system of linear equations, one being y equals 2x minus 1, and then the bottom one is 2x plus 3y equals negative 7. So the first step here is to identify that this is substitution, so we did that. Right, and in this example, I put step 2, 3, 4, and 5 next to each other for the sake of cohesion and just logic. It looks good, right? So then I did 2x plus 3 And y is equal to 2x minus 1, so I put 2x minus 1 into 2x minus 1 equals negative 7. Then I distributed, so 2x plus 3 into 2x is 6x, and then 3 into negative 1 is negative 3, equal to negative 7. So then I combine like terms, so 2x plus 6x are the like terms, 8x, then I got 8x, minus 3 equals negative 7. Now, I added 3 to both sides in step 4, and that is equal to 8x equals negative 7 plus 3, which is negative 4. In step 5, I divided both sides by 8, and this got me x equals negative 1/2. And like I said, like we've been doing this whole video, we have to plug it back in to one of the original equations. Here, I just plugged it into the first one because it's easier to like understand. So y equals 2 into x, which is negative 1/2, minus 1. Y equal to 2 into negative 1/2 is negative 1 minus 1. Negative 1 minus 1 is negative 2. Okay? So y equals negative 2. So the solution is negative 1/2, negative 2. And then our last method, our fourth method, is solve by graphing on our calculator. In this case, I used TI-84, but you could also use TI-89 to graph systems of linear equations, and then you could determine the solution by looking at where the two lines or graphs intersect. Alright, so as you can see here, I used the two equations 2x minus y equals negative 2, y equal to x minus 1. So I can't have it in the standard form 2x minus y equal to negative 2, so I put it equal to y. So I isolated for y, and I got y equals 2x plus 2, and obviously y equals x minus 1 was already in the form that the calculator likes. Alright, so I plugged it into the calculator. As you can see in the first calculator screen, I put y equal to 2x plus 2, and then y equal to x minus 1. Then I hit the graph button, as you can see in the second one, and then you have the two lines, the two graphs, right? And then how you actually find the intersection point or the solution is you have to press second trace, right? And then you'll have like a list of options being like 0, value, intersection, all that, right? Then you just press intersection, and then it'll tell you, okay, mark the lines. So you put like where the left bound and right bound of the lines are, and then you get the intersection. So the intersection is negative 3, negative 4, and that is also our solution in this case. So altogether, these are the 4 different ways you can solve systems of linear equations in the coordinate form, the coordinates being x, y. And I hope this video helps you in the future. And the standardized tests, these show up on the SAT, ACTs, all of that, right? And also this can show up on tests that you might have too. So I hope this helps. And in the link down below, in the description down below, I will put some links to the websites I used to actually like get some of this information. Right, so check those out too if you need any further assistance.